All right, we are going to talk about ionic compounds. We're going to talk about naming, and we're going to talk about formulas. Okay, remember, ionic bonds form because of the strong attraction between positive and negative charges. So between that positive cation and that negative anion, we get ionic bonds. We can have monatomic ions, so ions that are from a single atom that has lost or gained electrons, or we can have polyatomic ions, where we have different atoms covalently bonded that end up with a charge and are either an anion or a cation. So let's do naming first, naming ionic compounds. So you were given a flow chart. Looks like this, the whole paper. So naming compounds, that's what we're talking about first. That's the whole sheet. I'm going to break it down step by step. So here's our first one, MgCl2. So I have to name it. So is there a metal or NH4? Well, yes, Mg is a metal. That means it's ionic. All right, so we're at that step. So what's the positive ion? Well, the magnesium ion, the positive ion is the one that's listed first. So remember, we're at the positive ion. Now we have to go on. So we check the periodic table. Does the element have more than one oxidation state? Well, look at magnesium on the periodic table. Negative, it has one oxidation state. So since it has only one oxidation state, we're at the no, so we go down here to this. So that means we just call it magnesium. So here we are at this point, we just call it magnesium. So what's the negative ion? Well, it's Cl. It's monatomic. It's one single atom, one ion. We're going to add IDE to the stem of the atom's name. So it's chloride. It was chlorine. It became chloride. And then we're going to combine the names together. So we get magnesium chloride as the name of MgCl2. All right, let's try another one. Here we go. Is there a metal or NH4 plus? Well, yes, I literally see there's NH4. NH4 is there. So that means it's ionic. So since it's ionic, what's the positive ion? Well, we just said it was NH4, right? The name of that from table E is ammonium. Okay, so ammonium, remember the positive ion is listed first, and the name of it is ammonium from table E. So we already have the name of the positive ion, so we can skip past all of this. So we know ammonium is our positive ion. So what's the negative ion? That's the step we're on now. Well, it's PO4. That's what's left. That's polyatomic, which means we need to check table E. When we check table E, when we look for PO4, we can see its name is phosphate. So we have phosphate as the name of the negative polyatomic ion. Now we combine the names. So ammonium phosphate is the name of NH4 in parentheses because I need 3 of them. That's what that 3 means. And then PO4 phosphate, ammonium phosphate. Let's do another example. Is there a metal? Well, yes, Fe is a metal. So that means it's ionic. So we said it was ionic. So what's the positive ion? Well, iron, Fe, the positive ion is listed first. So we got to check the periodic table. Does the element have more than one oxidation state? Yes, it does. So now I have to use a Roman numeral for the ion's charge. Okay, so how am I going to figure out the charge? Well, it's either +2 or +3. I can't guess. So how am I going to figure it out? Well, this formula is like I have one of these and then I have this. So the charge of SO4 from table E is -2. So if the SO4 is -2, then the Fe has to be +2 to balance it out. So we have to call it iron with a Roman numeral 2 in parentheses. So my positive ion is iron 2. So what's the negative ion? It's SO4. That's what's left. It's polyatomic. So that means I look at table E right here. Sulfate is the name. So sulfate was the name of the negative ion. I combine the names. We get iron 2 sulfate. So FeSO4 is iron 2 sulfate. Let's look at another example. Is there a metal? Yes, Cr is a metal. So it's ionic. So since it's ionic, what's the positive ion? Well, chromium ion, the positive ion, is listed first. Chromium ion. Check the periodic table. Oh my goodness, it has so many. So yes, we have +2, +3, and +6 as options. So I have to use a Roman numeral. Okay, to find the charge, I'm going to reverse crisscross. Since there's only 2 elements. When there's only 2 elements, reverse crisscross is the way to do it. Easy peasy. What do I mean by reverse crisscross? So if I have this formula, Al2S3, the 2, that is the subscript for Al, was the charge for S. And the 3, that is the subscript for S, was the charge for Al. So in this formula, I reverse crisscross, and I find out that the charge on Cr is 3 plus, and that's one of the options. So it is chromium 3. So chromium 3 is the name of the positive ion. So what's the negative ion? Well, just O. It's monatomic. So we add "ide" to the stem of the atom's name. So oxygen becomes oxide. So then we build it all together, combine the names, and it becomes chromium 3 oxide. All right, so those are 3 ways to name, well, 4 ways. We did 4 examples of naming ionic compounds. Now it's time to write ionic formulas. So you were also given a flow chart, looks like this, the whole thing all together. All right, so calcium sulfide. All right, so do we see prefixes? No, so it's ionic. So it's ionic, so now we go, is there a Roman numeral? No, there wasn't a Roman numeral. Is NH4 first? So do I see ammonium? No. So I use the oxidation state on the periodic table as the charge for the first element. So right there. So it's going to be Ca2 plus. And this is typically how we write it, with the 2, then the positive. Look at what's left. Monatomic. How do I know it's monatomic? Because sulfide comes from sulfur. And sulfide is also not on table E. So there's a double check. So use the first oxidation state on the periodic table. So look at that list, use the first one. So we're going to use 2 negative. So now we're going to balance the charges. The crisscross method works really well. So we have calcium with a 2 positive and sulfur with a 2 negative. We crisscross like this, which means we end up with subscripts of 2. Now we have to reduce to lowest terms. That means I don't want to leave 2 and 2. So I'm going to reduce it to just CaS. So that is the formula for calcium sulfide. Let's try potassium nitride. You see prefixes? Nope, so it's ionic. Since it's ionic, is there a Roman numeral? Nope. Is NH4, is ammonium the first word? Nope. So we use the oxidation state for the first element. Well, potassium is K, so that's our charge, plus. And we don't write the 1, so just plus. Now look at what's left. It's monatomic. How do I know it's monatomic? Nitride comes from nitrogen, and also, as a double check, nitride is nowhere listed on table E, so it had to come from an element. So use the first oxidation state on the periodic table as the charge for the second element. So nitrogen had a giant list, but we use the first one. So now we're going to balance the charges, and crisscross works well. So here's what we had. We're going to crisscross, and the charge number is going to be the subscript here. The charge number is going to be the subscript here. So we're going to end up with this. Then we reduce to lowest terms. We just never, ever, ever write a 1. Don't write the 1. So it's just going to end up like this. So K3N is the formula for potassium nitride. All right, let's look at another example. Tin IV permanganate. No prefixes, so it's ionic. Is there a Roman numeral? Yes, there is. So use the Roman numeral as the charge for the first element. Well, IV is what? 4. So tin 4 positive, I know. And it's one of the options that tin has. Look at what's left. Is it monatomic? No. Well, first of all, I looked and looked and looked on table S and I didn't see any kind of version of permanganate. So check table E. Permanganate is listed on table E. So look up the charge. Well, that's the formula for permanganate, and that's the charge, just -1. And we don't write the 1. So now we're going to balance the charges, and crisscross works well. So we're going to take the 4, the number of the charge, and bring it over here. And we're going to take the number of the charge for this one and bring it over here. But here's what I have to be careful of. Since this is permanganate, I need to put it in parentheses to keep it together. Okay, so the MnO4 is a unit. And this 4 means I have 4 of that whole unit. And now remember, I have to reduce to lowest terms. I don't write ones. So it's going to end up as Sn parentheses MnO4 end parentheses 4, meaning I have 4 of the permanganates and 1 of the tin. All right, so now we're going to do a lot more practice on the sheet, but that is ionic compounds naming, and ionic compound formulas. I hope that helped and you learned something new.